Okay, so let's continue on discussing all about the median. How do we come up with the value of the median for a group data? So basically, a while ago the app crashed, so that's why I wasn't able to notice that it was not recorded. So I have to redo the discussion again involving the median. So, but anyways, let's try to go through with that. So again, the median is actually for um, raw data is the still an average of a set of numbers, but for me median for the raw data it's different. We've done that the last session. For a data set that is odd, that is just the middle number, and then if it's going to be even, that would be the two middle numbers. You get a mean, that is going to be the median of your raw data. Now we're gonna deal with the median for the group data. These will be involving the class intervals. So for group data presented in frequency distribution, the formula used for the median is equal to x of LB plus the quantity of n divided by 2 minus the cumulative frequency of f sub b divided by f sub m times c, where x of LB is equal to the lower boundary of the median class. The cumulative frequency of f sub b is equal to the sum of all the frequencies before the median class, and f sub m is equal to the frequency of the median class, and n is equal to the sample size, and c is equal to the class size of the intervals of what that was created. So let me just um, explain to you how do we apply this formula using same data set. So a while ago we calculated for the mean, which is 38.97. We are also making use of these frequency distribution table in order to find for the median. So let me just crop up this part where we use this formula so that we don't have difficulties in defining it. So that would be this one. So this would be the class intervals. This would be our formula and its notations used. And by the way, there might be other statistics professors that would use a different formula. You might notice they have different notations, but again, they are used in the same context, meaning they have the same meaning. So again, they are just using different variables. Again, when we discuss about MMW, we define what is a variable, and variable can stand in for any value as long as the meaning of these notations are the same. They are the same formula. Okay, so we're gonna use that one to find our median of the data set. That is gonna be the formula. So we're gonna find out which are these, and then divided by f sub m times c. Okay, so your x of LB here refers to the lower boundary of the median class. Now the problem is, how do we find for the median class? So the median class uh, would be, if you are going to find it or you are going to locate it, is going to be greater than your n divided by 2. So your n here is 30. So that means your n divided by 2 is 15. So 15 is going to be in between 9 and 16 in terms of these cumulative frequencies. So basically, our median class could be either in our 25 to 31 or 32 through 38. So for this case, we are going to use 32 to 38 because it's greater than 15. Yung cumulative frequency niya, which is 16. So we're gonna highlight that one, that this is gonna be our median class. So this is our median class. Let me just write that one. Median class. Okay, that is our median class now. And then what will be the lower boundary of this median class? The lower boundary of this median class is 31.5. So we'll just write out one, 31.5 plus your n divided by 2, which was calculated a while ago, 15 minus your cumulative frequency of f sub b, which is basically adding up all the frequencies before the median class, which are 6 and 3. It will give you 9 divided by 7. Okay, and that will be 31.5 plus this is gonna be 15 minus 9 is gonna be 6. 15 minus 9 is 6 divided by 7 times 7, and these can be cancelled out, so it will give you 31.5 plus 6, which in turn would give you 37.5. So basically this is gonna be our median for these grouped data. So that's how easy it is to find the group, the median for the group data, as long as you know as to which these notations refers to. Okay, and also we can calculate for the mode of the group data. So what is going to be the formula now for the mode of a group data? So for the mode of the group data, for group data presented in the frequency distribution, the formula used for the median is going to be x, this one, I mean mode is equal to x sub lb plus d sub 1 divided by d sub 1 plus d sub 2 times c, and then x sub lb here refers to the lower boundary of the modal class, d sub 1 be the difference of the frequency of the modal class and the frequency of the interval before the modal class, d sub 2 is be the difference of the frequency of the modal class and the frequency of the interval after the modal class, c is going to be the size of the class interval. So let's try to apply that one, and let me just add up another page wherein we could write down things so that we can properly discuss for the mode. So we are going to do we are going to use the same data set, and then let me just paste that one here, and then find for our mode of the group data. And also let's try to crop up this portion as well to find our mode using these definitions of the notations. So that would be x, or the mode is equal to x sub lb plus d sub 1 divided by d sub 1 plus d sub 2 times c. Now, x sub lb here refers to the lower boundary of the modal class. So, saan ba nakalocate si modal class? Yung modal class natin is going to be determined by finding out which class interval has the most frequency. So for this case, that is still the same as the median class, which is here in 32 to 38. So basically, that is still our modal class. So still, it has the same lower boundary, which is 31.5. So we notate that one. We take note of that. And then for the d sub 1 and d sub 2, it's a difference between the frequency of the modal class and the frequency of the interval before the modal class. So as you can see, before these modal class, we still have another class interval, which is 25 to 31, and it has a frequency of 6. So you are going to take out the absolute difference of the frequencies of these intervals. So that would be 7 minus 6. Now, the absolute value of 7 minus 6 is 1, and it's still equal to 1. So therefore, that is 1, and then 1 plus another difference, and it's going to be in terms of your frequency after the modal class, which is 4. So that is going to be d sub 2, the absolute value of 7 minus 4. So that is going to be d sub 2 is just the absolute value of 3, which is still 3. So that is going to be 1 divided by 1 plus 3 times 7. And this is going to be 31.5 plus 1 divided by 4 times 7, which will give you 31.5 plus 7 over 4. So we just have to find out what would be the value ng 7 divided by 4 natin. So if we use a calculator right here, a scientific one, it'll be 7 divided by 4 is 1.75. Then we add these values, 31.5 plus 1.75 is 33.25. So basically, our mode is 33.25 for these data set. So again, that's how you calculate for our mode. And that is all, I think, for our measures of central tendency for the group data. We still have to talk about the measure of dispersion in terms of group data and measure of relative position the next meeting. So for now, I'd like you to work on the activity that is here using what I have discussed in this video, and then we are going I'm just going or we are just going to find out the answers the next meeting, and I'll just choose some presenters to explain their answers so that we could work through every uh, um, confusion or questions that you have involving measures of central tendency for group data. Anyways, I think that's all for now. Goodbye.